Welcome guys to EDA. Here seeing is a motorcycle charging system. So what it is this kind of three-phase coil which stands here in the part of the engine, and there is a magnetic rotor that rotated by the crankshaft, and you have two sets of connectors. One is for the crankshaft sensor, the other one is for neutral, and this is the three-phase wire. This three-phase wire is there to take the three-phase and get it to the regulator rectifier. Now this is not like a normal alternator. This is like a coil that is going to be converting the magnetic field that is incident upon it, and then it will convert it into AC and sends it to the regulator rectifier. So let us see the waveform here. So we can see the perfect three-phase waveform. Red, blue and green. These are the three waveforms. Let us run the scope and you can see the... Now when I rev up the engine, you can see the field coil go up to 80 volts. So this is what you have seen. The waveform is when you unplug the stator coil from the regulator rectifier. Here is the other part of the connector which connects to the regulator rectifier here, and then it charges the battery. Now the problem is for about cyclic period of time, these regulator rectifiers goes, they say that it shorts it or some kind of issue that burns up the coil. So this person is keep on changing the coil. So he fed up with it, came for the diagnostic. So we diagnosed it, but I am in for a treat. I never put a coil on a coil voltage, and I never put it on a motorcycle. So what we see is an AC alternate waveform which is perfect. But let us see when we connect it, and then we explain the system. Now as you can see, let us pause this. Let us bring this. Now when you see this to a naked eye, it looks like a short because the line is straight. As you can see from the above video, that the line is curved. It's how the AC waveform should look, but here we see a short on all the coils. Let us run the scope. You can see all the coils are having this kind of an issue. Now this is not a fix. This is not a short in the regulator rectifier. So when I connected this, and then when I connected this to a scope, when I done the scope measurement, I found it to be a regulator rectifier problem. But here comes the knowledge of regulator rectifiers. So when you see this is the stator coil, three-phase of stator coil that is connected to 6 packs of diodes. One is going to the battery positive, the other one goes to the negative. But here comes the normal part. There it comes, and here you have a MOSFET. That MOSFET is connected to the ground. Here it is actively reducing the voltage so that it doesn't spike the system and damage the diodes. That's why this system, this is the rectifier system. This is the regulator part of the system. Here it cannot control the magnetic field. The magnetic field, when it spins faster, it is going to create more than 80 volts at a time. 80 volts at a time cannot be handled by this system. That's why what we are doing is, we are actively regulating it with kind of a MOSFET, and it is actively clipping the circuit. This is not like your car alternator where you can see that the alternator is here. When you see the alternator, here you have a stator coil and field coil. When you see the field coil is actively regulated by a voltage regulator, which is not possible in case of this system. Here magnet is rotating around the stator coil. It cannot reduce the field strength of that magnet. So here what we do is, here we short out the system. So let us see how it looks on the scope. Let us run the scope. Now if I rev up the engine, you can see that it will not cross beyond certain threshold. So as you can see, the top line of the system is not changing. The threshold is not going up. And here you can see the charging voltage. It is around 14.5 voltage. So the system is good. But when you diagnose it and when you touch the coil wire, it tends to heat up. Here this coil wire, this regulator rectifier, this area becomes very hot because the regulator rectifier resides behind this panel. This all becomes hot. So naturally when you come to a conclusion that this coil is producing voltage and this is turning it into a heat and this is heating up, so naturally in our mind we think that something is getting shorted. So we see that cable also getting heated up. When you overlay the thermal imager on this, you can see that red color as well, which is heating up the system. This is the normal operation. Until you know the circuit, you cannot diagnose the system. This is the know-how I've been kicked around when I try to diagnose the system. When most of them will change stator coil, regulator rectifier as well as the battery. All three together they will change it. But here it is different.